Hello, dear students. In this video, I will discuss about the first unit, electrostatic, electric charge, Coulomb's law, Gauss's theorem. I have delivered uh, notes regarding these topics in the WhatsApp group. Here, I would like to explain uh, briefly uh, regarding these topics. First of all, the question arises in front of us, what is electric charge? Electric charge, there are two types of electric charges, positive one nature and negative another nature. Electric, electric charge can exist only on a massive object, only on a massive particle. Without massive particle, the imagination of charge is impossible. Electronic theory of charge tells us when we rub two objects each other, then some electron may be lost by one object and some electron may be accessed on the another object. In this way, opposite charge come there, negative in one and positive on another. We talk about electric field. What do you mean by electric field? Electric field is simply a region or a space around the electric charge where any electric force, whether it is repulsive or attractive, can be experienced. That field or region is called electric field. Now the question arises here: what is electric field intensity? As we know, physics is the science of measurement. Measurement is the important part of physics. Every physical quantity which is measurable, force, mass, current, pressure, impulse, etc., etc. In the similar way, electric field intensity tells us the measurement of electric strength, how much electric field is stronger and how much it is weaker. The mathematical definition of electric field is that electric field intensity at a given point in the electric field may be defined as the magnitude of force, electric force experienced by unit test charge particle. This is the mathematical definition. In mathematical way, you can give it by the formula vector E is equal to vector F upon Q naught. Test charge. Test charge is a imaginary charge. Uh, it has positive nature and its magnitude is very small. A very small charge, positive charge, which is imaginary, can be treated as a test charge. On the basis of this test charge, we can give the definition of electric field strength. Electric force lines are imaginary straight lines or curves uh, which are used to represent the electric field. If the electric force lines are very close to each other, then it indicates the stronger electric field. If they are far away, uh, less dense, then there will be weak electric field. Electric dipole. Electric dipole simply it is a system of two opposite charges having same magnitude, and these opposite charges are placed at a finite distance. This system is called electric dipole. For example, the molecule of hydrogen chloride may be treated as an electric dipole. Similarly, sodium chloride, sodium has positive charge and chloride ion has negative charge, and these two ions are placed at a very small distance. So this is called electric dipole. And when we rotate the electric dipole in an uniform electric field, then two opposite forces F is equal to QE, F1 is equal to QE, and F2 is equal to QE act together but opposite in direction. In this way, these electric forces make a couple, and in this way, as a result, the electric dipole will experience torque due to the electric field, and the expression may be given by tau. Torque tau is equal to Pe sine theta, where P is electric dipole moment. And in my notes, you have seen that there are some large derivations. You have to practice them and note all the derivations in your fair copy. There are two large derivations: electric field due to dipole on axial position and electric field intensity due to dipole on equatorial position. These are two very important topics. Uh, Frequently, these derivation asked in board examination. After this, we enter in another topic: electric potential. Electric potential is a scalar physical quantity. It is very important, and sometimes we say electric potential in common language voltage. Potential in the electric field mathematically can be defined as the work done in bringing the unit test charge from infinity to that particular point. This is the mathematical definition of electric potential. Electric potential V is equal to Q upon W upon Q naught. Unit of potential, unit of potential or voltage is volt, and higher order units are kilovolt, million volt, etc. And some lower order units are millivolt. 1 millivolt is equal to 1 upon 1000 volt. 1 microvolt is equal to 10 raised to the power minus 6 volt, and so on. The important term come in this lesson: electric potential energy. What is electric potential energy? The electric potential energy of a system of or group of charged particles may be defined as work done in bringing these charged particles from infinity to a particular positions. This amount of work may be defined as electrostatic potential energy. The expression for electrostatic potential energy will depend upon the different group of the different system of charge particles, whether the system may be of two charge, whether or the system may be the system may be the charges of three charge particles, and so on. In this lesson, there is a relation between electric field and potential difference. The electric field intensity is related with the potential difference. If there are two equipotential surfaces at a distance d and potential difference is delta V, then electric field intensity may be given by E is equal to delta V upon d. One thing more, equipotential surface. What do you mean by equipotential surface? Equipotential surface is an imaginary surface in the electric field where the potential on each point uh, be constant or same. When any charged particle moves across the equipotential surface, then the net work done would be zero. The third lesson of the first unit is Gauss's theorem. When we start the Gauss's theorem, first of all, we have to know about the concept of solid angle. Plane angle, we know it very well. The length of arc upon radius simply may be defined as plane angle, which is measured in radian, 4 pi radian, 2 pi radian, pi upon 4 radian, etc. It is two-dimensional angle. But when we talk about the solid angle is actually three-dimensional angle. It is the angle subtended by a part of surface on the sphere at the center of the sphere. The mathematical formula for the solid angle, which is measured in steradian unit, solid angle omega is equal to area upon radius square. Actually, this solid angle has very important role in explaining the Gauss's theorem. Now the second thing is electric flux. Whenever some electric force lines passes through any imaginary surface or any non-conducting surface, you may say that if the electric force line penetrate some area, some surface, then an electric flux will linked with it. Electric flux is a scalar quantity, and it is defined as the scalar product of electric field intensity E and area vector A. Vector E dot vector A, which is simply Ea cos theta. Now, what is the Gauss's theorem? Now you are in a stage to understand what is the Gauss's theorem after knowing about the solid angle electric flux. Gauss's gave a very fundamental law in the electrostatic. It is very important law. According to this law, the net flux or surface integration of the electric field through a closed Gaussian surface is just equal to the 1 upon epsilon naught times of total charge enclosed inside the surface. This is the Gauss's law, and with the help of Gauss's law we can deduct the Coulomb's law. These are some general things which I have to explain you in this video, and in my next video I will explain you what is the meaning of electrical capacity, and what are condensers, and the different combinations of condensers, energy stored in capacitors. All these topics I will discuss very briefly in the next video. Thank you.